Good morning, dear students. My name is G.K. Narasimhamurthy, an associate professor in the Department of Physics, DIT Bangalore. See, I'm going to teach you electrostatics. In electrostatics, what exactly we are or what exactly we are going to deal, that we should know. So, sir, our professor D. Nagaraj taught current electricity, continuous flow of charges is nothing but current. Now I am going to deal with a static charges. Static means the charges at rest. What exactly we are going to come across in this? Actually, we are going to come across, you can see. So field we are going to come across. Then the force experienced by the charges between any two we are going to come across. Then the potential we are going to come across. Then we are able to store the charges. We are able to store the charges in a device that is called by a name capacitor. Okay. So therefore, easily we can deal. So like this. That means now what is exactly or how we are going to exactly understand this electrostatics. I think during a rainy season, you have come across these things, a lightning, a thunder, and in your motorbike, you have come across a plug. Okay. So spark plug. Okay. Wherever you have come across heavy electric discharge, charges are going to be released from a body. That's right. But are we able to create a charges? Certainly we are unable to create the charges. Therefore, charges can neither be created nor be destroyed, but they can be transferred from one body to another body. That is most important. So the methods of charging, you know that by conduction, by friction, by induction. Induction plays very important role compared to the other two methods. So therefore, remember, certainly these electric charges is only, so the available charges can be transferred from one body to another. So that's why the net charge is always remain same. That's why we are calling by name conservation of charge. Let us see. So the formulas, whatever we have come across, we have to discuss here. Okay. So that's why we are calling by a name. This is synapses. Then I'm going to start. So question by question. Okay. The first one you can see quantization of a charge. That is the charge acquired by a body is plus or minus Ne, where N represents the magnitude, E represents the charge. When do you get a positive and when do you get a negative? Suppose from a body, if you are able to remove number of electrons, then the body is said to be electrically positively charged. Suppose the same electrons which you are removed, you cannot keep it. Okay, that they're going to add to another body. Whenever these electrons are added to another body, then we are going to say that it is get negatively charged. Therefore, how many charges which are removed or how many charges which are added, so is given by Q to plus or minus Ne. So usually 1 coulomb is the unit. 1 coulomb is a very big unit. So that's why we are going to use 1 microcoulomb, 1 millicoulomb, 1 nanocoulomb, 1 picocoulomb, 1 femtocoulomb. Like that. In 1 coulomb, you know how many number of electrons makes 1 coulomb. Okay. So that means 6.24 into 10 to the power. So electrons actually makes 1 coulomb. So that's why it is a very big unit. So because of that reason, we are going to come across 1 microcoulomb, 1 nanocoulomb, 1 picocoulomb like this. Okay. So therefore, first point, quantization of a charge is completely understood. Next, Coulomb's inverse square law. What is this? Whenever the two charges which are separated by a certain distance, either in air or maybe in any medium, then we are going to come across force of interaction. What is the force of interaction? One will experience a force on another one, or other one is going to experience a force on the other one. So this is given by, already you have studied completely in detail. Therefore, I'm going to mention that one. So force in air between any 2 point charges. So easily, if I want to write that one, then you can see that. So here, suppose here is a 1 charge. let me call as a Q1. Then it is separated by a distance from the other charge, Q2. If I call this as a distance D, then I can easily write, you can see this one, Fa is equal to 1 by 4 pi epsilon into Q1 into Q2 divided by D square. So the unit which we are using to measure is Newton. So now, suppose if you are placing in a medium, then what we are going to come across? See, here we have given, so just a simplified answer here, that is force between any 2 point charges in any medium, Fm is equal to Fa divided by epsilon r. In other words, actually when you place in a medium, so this completely what's called by a name relative permittivity or dielectric constant, you have to divide. Why? The force between the 2 point charges decreases. Force between the 2 point charges decreases. That's why we are calculating epsilon r. Epsilon r is equal to Fa divided by Fm. Even in the capacitor also, we are going to define epsilon r is equal to Cm divided by Ca. When I come to that point, I'm going to expand this. Now you remember epsilon r is equal to Fa divided by Fm. That means force between any 2 point charges placed at a certain distance of separation in air to the force between the same 2 point charges separated by the same distance in any given medium will give epsilon r. Since it is a ratio of forces, therefore it doesn't have any unit. Okay, here you are going to see the another term called by a name epsilon naught. This is called absolute permittivity of air or vacuum. So whose value, I think you know that one, 8.854. Okay, so that way, so we can understand completely the force of interaction between the 2 point charges. Are we going to stop at the same position? No, we are moving ahead. What is that? We are able to calculate what is called by name electric intensity. Electric intensity is nothing but the force experienced by any point charge, any unit positive charge placed at the vicinity of any other charge. So thereby E is given by the relation. Once again, I think you are calculated. E is equal to 1 by 4 pi epsilon naught into charge by distance square. Charge by distance square. Force experienced by a charge placed in the vicinity of electric field. Okay, so therefore easily we'll be able to understand that one. Whenever a charge is there, its field means of force are there. Any other comes very close to that one means we have to do some amount of work. In other words, there is a force of interaction. Electric intensity at that point. Electric intensity is nothing but force experienced per unit charge. So that's why E is equal to F divided by Q. The unit for this one is, easily we can say it is Newton per coulomb or volt per meter, because E also can be written as minus dV by dx. Minus sign shows only the direction. Therefore, I am writing this as a dV by dx. Then you can see, so completely what is called, so dV by dx means volt per meter. Okay, so this is the way easily will be understand completely what is called electric intensity. On the other end, we have given E is equal to 0 inside any conductor. E is equal to maximum on the surface of a conductor. On the surface of a conductor. Next. So you can see here, electric intensity due to a point charge or a spherical conductor or spherical shell. It is given by B. E is equal to 1 by 4 pi epsilon into charge upon distance square. Second one also we have given. So E, that the electric intensity is nothing but a negative potential gradient at that point. So that's why here is a relation which we have given. Electric intensity at any point is nothing but negative potential gradient at that point. negative potential gradient at that point. In other words, electric intensity keeps on decreasing. So when we are moving away from its charge, okay, that is the one. Next, are we satisfied with all these things? No, we are not satisfied. Human being is a person who never gets satisfied with respect to anything. Once he has understood one thing means he want to gather for another thing. Why? He want to make use of all the available things for his benefit. That's why he is not satisfied. Then you want to completely identify what is called by a name dipoles. What is a dipole? Any 2-point charges separated by a very small distance. So any 2-point charges separated by a very small distance is called by a name or constitute a dipole. What is a dipole moment? So either charge into a distance of separation between them will give dipole moment. It is represented by P here. Therefore, P is equal to either charge into distance of separation between them. P is equal to Q into, okay, Q into 2A. 2A is the distance of separation between them. Now, we want to calculate completely electric intensity due to the dipole along its axis. Along its axis. If you want to calculate along its axis, you can see this one. Electric intensity is equal to 1 by 4 pi epsilon naught into 2p divided by r cube, where P is momentum. Okay, dipole moment. Next, along the axis, this is the equation. So then equatorial means equator. So then if you want to find out the equator, you can see the another relation, electric intensity due to the same dipole along the equatorial line. Now you can see 1 by 4 pi epsilon naught into momentum divided by r cube. In other words, here itself we can notice this one. E, electric intensity in case of a dipole is inversely proportional to the r cube. This you have to remember. So because we may going to use this relation, because we need not to change this one. So directly proportional to the moment and inversely proportional to the square of the cube of the distance of separation between them. Okay, now so we are completely dealt with dipole. Suppose a charges distributed on a linear body, means one dimensional. Okay, linear conductor. For that also we'll be able to calculate electric intensity. Electric intensity is equal to, so 1 divided by 2 pi epsilon naught into lambda by r, wherever you are calculating. So that one. So that is completely the next equation. Next, so here is a one plane surface. In this one, sorry, there is a typographical error in this one. That's why I have replaced this one. So easily, electric intensity is equal to sigma divided by 2 epsilon naught, where sigma is called surface density of charge. Surface density of charge, sigma is equal to charge per unit area. Charge per unit area. Suppose if a spherical conductor you are considered, okay, then charge is, if a charge q is distributed on the surface of it, then sigma is equal to total charge distributed upon area of that one. That is nothing but 4 pi r square. 4 pi r square. But electric intensity due to the plane surface is given by completely q, sigma is equal to q upon 4 pi r square. Remember here, so suppose they are giving two spheres which are of different radii, then charge may be distributed in a different way. That's why surface density is also proportional to 1 by r square. So remember this. Certainly it will help you to do or solve some of the numericals or some of the what is called by name CET problems. Next. So here certainly they are never going to ask a question on direct use of all these equations. only the deviations. That means it is something like this. What is the dependency of electric intensity with respect to the distance? So how two spheres which are R1 and R2 are the radius, they are given a charge Q1 and Q2, compare the charge densities, compare the charges, compare the radii. Okay, so that's why these deviations you have to remember correctly. Then only we will come across this. Otherwise, certainly it will be a problem for. So problem will arises because without knowing all these deviations, you cannot solve all the problems. Remember this. I think you are completely understood this. Let me move on to the next one. Next, are we stopped there itself? No, we are completely moved to a next point called potential. What is the meaning of a potential? Potential means it is the amount of work done to bring or displace a unit positive charge from infinity to a point under consideration against the field. Against the field. Since we are doing the work against the field, whatever the work we have done or whatever the energy we have spent will be stored inside that point as a electric potential. That's why V is equal to, you can see this one completely. So this W divided by Q naught. Q naught is the unit charge. Suppose we want to move any other unit positive charge, then so potential at any point, you can see this one, V is equal to 1 by 4 pi epsilon naught into charge divided by distance. It is a scalar quantity. It is a scalar quantity. Therefore, we can keep adding. Potential due to a positive charge is always a positive. Potential due to a negative charge is always a negative. What is the unit we are using here? It's equal to 1 volt. Then we can define 1 volt here. 1 volt is equal to 1 joule of work is done to move 1 coulomb of charge from infinity to a point under consideration of 1 meter. Easily we'll be able to define so that also. Then dipole moment. In the previous only I said, here you can see the dipole moment is nothing but the product of either charge into a distance of separation between them. Q into 2A. So the unit is coulomb meter. So what is the direction with which we are going to measure this one? Its direction is always measured from negative to positive. Actually, the electric field direction is always measured from positive charge towards the negative charge. But dipole moment is always measured from so negative to positive. So please remember this. It is opposite to the measurement of so completely the direction of electric force. Okay. So now torque experienced by the same dipole in a uniform electric field. Let us say the electric field is acting like this. The first line of force, this is the second line of force, this is the third line of force, this is the fourth line of force. Suppose here is a dipole. Here is a one charge, here is a negative, so another charge. Okay. So here another charge means, so this is minus Q, this may be a plus Q. So this may be making an angle theta here. Okay, so thereby I think usually you know that one. So this will be in this direction, this will be in this direction. So thereby easily we'll be able to calculate. So the torque experienced by a dipole when it is placed in a uniform electric field of intensity E. Okay, so that is given by here. So easily you can see E into P into theta, where theta is the angle made by so this dipole axis with respect to the uniform electric field. Then from theta itself, trigonometric function itself, we comes to know that one. So this is maximum as well as minimum. When it is maximum, easily you will be able to understand this one. When theta is equal to 90 degree, sine 90 is 1. So therefore, torque is equal to just EP. Okay. Suppose, so it is equal to 90 degree, then easily you can say that it is equal to 0. When it is maximum, when it is minimum, you should remember. You should remember. Okay. So then the unit of this you mentioned here, it is Newton meter. we don't know whether they are asking a very simple question or a very complicated question. So that's why you have to please concentrate on each and every point which we are dealing here. Okay, so please, work done on the dipole, nothing but energy stored, nothing but energy stored. So therefore, energy is given by E into P into cos theta 2 minus cos theta 1. Cos theta 2 minus cos theta 1. The next one and most important one which we are going to deal now is called by a name electric flux. What is a flux? It is a line. It is a line originated, or it is a line of force originated from any charge. Suppose you have taken a positive charge, all the lines of force are completely divergent. The meaning is, suppose if you have taken this as a charge, positive charge, then all the lines of force are normal to the surface of origination and they are moving away from the body. Suppose here you have taken a negative charge here. Then how? So all the lines of force are converging. So that's why we are calling by a name this as a convergent field, this as a divergent field. Convergent field as a divergent field. Remember one thing, it is also a measure of electric intensity. Nothing but force experienced by a unit positive charge assumed to be placed at that point. Okay, how many number of lines of force passing per unit area decides the intensity at that particular point. If more flux is passing through that, immediately you can come to a conclusion that intensity will be more. Intensity will be more. If less number of lines of force passing per unit area, so certainly intensity will be less. So that's why easily please remember, it is nothing but a measure of electric intensity. The line of force which originates from either a positive charge or maybe a negative charge is also a measure of electric intensity. Then how are we calculating? Dy is equal to EDS cos theta. You know that one. EDS cos theta. So thereby theta, usually they are normal to the surface of origination. Therefore, theta is equal to 90 degree. So that's why V dot ds we are going to come across. Okay, unit for theta. So voltmeter or maybe Newton meter square per coulomb. Newton meter square per coulomb. Please concentrate on these points also, the units. Okay, it is always a scalar quantity. It is always a scalar quantity. Next, we want to calculate what is the energy stored in the three charges. Three charges. Energy stored in a system or charges. U is equal to, so derivation you did it, therefore I need not to repeat much here. So U is equal to 1 by 4 pi epsilon into Q1 into Q2 by D1 plus Q2 Q3 divided by D2 Q3 Q1 divided by D3. So this way easily you'll be able to calculate the energy stored in the system. Okay, it is measured in joule. So if you have any doubts, please send, then I can answer the questions. Okay, so next one. There are some physical quantities over which we have to find out what is called by a name dimensional formula. Okay, so whenever you find out a dimensional formula, so please, these are the four. Yesterday I think I heard that sir, Professor Nagaraj has completely given the hint to calculate what is called by a name. So this calculation of or completely find out of this dimensional formula. Okay, suppose we want to find out a dimensional formula for this one. So we know that one FA or F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by D square. Let me derive at least one among these. Okay. If I want to calculate for epsilon naught, let us say this is equal to force I'm going to transfer to this place into Q1 into Q2 by D square. This is the value. Okay, then I can substitute the completely the unit. This is 1 upon Newton. So force unit is Newton. This is Coulomb. This is also Coulomb divided by. So this is completely distance. Therefore, meter square. Okay. So Newton, you know, kg meter per second square. Therefore, 1 upon. So this is kg. This is meter per second square. Okay. Then Coulomb is nothing but 1 ampere into 1 sec, completely time, 1 second. So therefore, I can call this by a name A into T divided by meter square. Okay. Now you write the dimension. So this is a kg. Therefore, completely m. That's why I write m power minus 1 in the denominator. So plus 1 denominator, if I take to the numerator, it becomes minus 1. So meter and meter square, both are there in the denominator. I want to the numerator, therefore L power minus 3. Next, second square, denominator of a denominator. This is a denominator of a denominator. Therefore, it goes to the numerator. Here you can see, I have written only 1 ampere and T multiplied by 1 more ampere and 1 more T. Why? Coulomb into Coulomb. Coulomb into Coulomb. So that's why I can say second denominator of a denominator, which goes to the numerator. Here are 2 more. Therefore, I can T to the power of plus 4. Okay. T to the power of plus 4. Right? Next. So then here, so ampere and ampere is there. Easy can say is ampere square. Now look at that. M power minus 1, L power minus 3, T power plus 4, A power plus 2. That is the dimensional formula for absolute permittivity. That is epsilon naught. Easily, like this, we will be able to calculate the dimensional formula for electric intensity, moment, electric flux, as well as potential. You can see this is nothing but F1, L power plus 1, T power minus 3. This is A power minus 1 is the dimensional formula for electric intensity. See, distance in completely. So charge A into, that's why M power 0, L power 1, T power 1, T power 1. Electric flux, M power 1, power plus 3, 1, A power minus 1. Electric potential, power 1, L square means L power 2, T power minus 3, A power minus 1. Okay, so please completely practice this. Then you will get a confidence of writing dimensional formula of any one of the quantity. Simply, there is a chance of asking dimensional formula of anything. Okay, so let me move on to the next one. You can see here dielectric constant epsilon r. It has no unit. For a metal, it is equal to infinity. Okay, what are dielectrics? Dielectrics are basically insulators. They do not have free electrons in the last orbit. So therefore, they do not conduct heat and electricity. But when the dielectrics are placed in an applied electric field, immediately they behave like a polarizers. What is the polarization means? Displacement of positive and negative charges. Displacement of positive and negative charges when or due to the application of external electric field is called by a name polarization. Depending upon the magnitude of the polarization we have come across in a material, it will be having its dielectric constant called by a name epsilon r. Called by a name epsilon r. I think you are able to understand. So these dielectrics. So what are these? Dielectrics are basically insulators. They do not have free electrons in the last orbit. Therefore, they do not conduct heat and electricity. In other words, all dielectrics are insulators. Otherwise, means in other words, all dielectrics are insulators. but all insulators are not dielectrics. That's why insulators can be bifurcated into two categories. One is called by name dielectric insulators. Second one is called by name pure insulators. Okay, that's why these dielectrics plays very important role because they are helping us to store or to increase the storage of charges. To increase the storage of charges, we are going to use these dielectric materials. That's why it is important to study regarding this. For air vacuum, we are going to take it as a completely standard one. That's why epsilon r is equal to 1. For any substance, epsilon r is greater than 1. Okay, so this you have to remember. For a metal, it is equal to infinity. That also you have to remember. Okay, some of the definitions, whatever you have studied, we have given it. Just if you go through this one, you'll be able to understand that one. Okay, the space surrounding an electric charge in which another charge experiences a force is called electric field. I need not to tell you, already you have studied, so you are prepared. Okay, the direction of the electric field at any point is given by the direction of the force on a unit positive or test charge placed at that point at some point distance r from the center of the dipole at a distance r making an angle theta with an axial line E is equal to 1 by 4 pi f naught into P by R cube into square root of 3 cos square theta plus 1. I need all these things I have given only to just go through this one to remember the formula. Okay. Next, Gauss theorem, most important thing to calculate. So this one, the total outward normal electric flux, the total outward normal electric flux from any closed surface, is equal to 1 by epsilon naught times the total charge enclosed by the same surface. That means it is also a measure of electric intensity. It is also a measure. How? So easily I'm going to give the equation. You can see that one. Okay. So there it is not given. That is completely. So I can write this one, this as a completely what is called by a name total outward normal electric flux. Phi is equal to, so completely 1 by epsilon naught times the total
Total
charge
charge
enclosed by
enclosed.
that surface. Total charge enclosed by that surface. It is also a measure of electric intensity. We can calculate. So by using this method also. Okay. So let me move on to the next one. See. Now, net electric field inside a dielectric material, E applied minus E induced, or EA divided by epsilon r. Anyhow, this is the formula which you have derived in the equations. So that's why this chapter also, I mean, these points also, I think you are repeated. Just the definitions are given just to understand this one. Potential at a point in an electric field is a measure of amount of work done to bring a unit positive charge from infinity to a given point against the direction of the field. If a charged particle is accelerated through a potential difference of V volt, then the kinetic energy acquired by the particle is given by half mv square is equal to EV. We have come across two types of energies, remember. One is called kinetic energy, another is called potential energy. What is a kinetic energy? Kinetic energy is possessed by all moving particles. Potential energy is due to the position. Okay. So therefore, whenever any particle, if we make them to move from the rest, then it starts gaining the velocity. Rate of change of velocity is called by name acceleration. So therefore, when it is accelerated, then it's going to get a kinetic energy. There is a standard expression for kinetic energy that is given by half mv square. That is nothing but, suppose a charge is accelerated. A charge means a charge into the potential in which it is accelerated. That's why it is given by an equation E into V. Means charge into the potential into which it is sent in. Okay. That's why here we have given completely what is called by name half mv square is equal to EV. Suppose we want to find out a velocity. If you want to find out a velocity, then easily I can write V square is equal to, so completely one here, then 2 into EV. Okay. So divided by M. Okay. Suppose I want to find out only V, then easily I can write that. So V is equal to easily square root 2 EV, so by M. This is the way with which you'll be able to calculate what is called by name velocity acquired by that one. Okay. Certainly, they are not going to ask the problem on this way. What is the velocity? Such a simple problem, they never going to ask it. They are saying this one. One is a alpha particle. You know that one 2He4 is nothing but an alpha particle. Okay, an alpha particle and a proton is thrown into an electric field with a velocity or acceleration. They're going to give you. Okay, then compare their velocities, compare their masses. Okay, so that's why I have given the next two. You can see this one. These three, A, B, and completely this are very, very important. Please note it. 100% you are going to get one question from this one. Okay, if a charged particle is accelerated through a potential difference of v volt, then the kinetic energy acquired half mu square is equal to EV. Please remember this, and the velocity calculation I have given. Next, the ratio of kinetic energy acquired by the two particles. This is what I've given as an example. The ratio of kinetic energy acquired by the two particles accelerated from rest through the same potential or in the ratio of their charges. Kinetic energy, if you are comparing kinetic energy 1 is to kinetic energy 2, means kinetic energy acquired by the first particle to the kinetic energy acquired by the second particle is equal to same potential. Therefore, E1V is to E2V. Since V remains same, we can remove it. We can remove it. Therefore, Ke1 is to Ke2 is equal to E1 by E2, or easily you will be able to compare Ke1 divided by Ke2 is equal to E1 divided by E2. Now, it is such a small relation. It seems to be a small relation, but they're never giving completely direct one. They're going to say that one is an helium, another one is a alpha particle, or one is a proton, another one is an alpha particle. Like that, they're going to give a different masses also, different charges also. Okay, so that's why please remember this equation. You will be 100% come across maybe a one question. So based on this, okay. Next, the ratio of the velocities acquired by the same two particles accelerated from rest. Okay, just now I discussed there. So therefore, V1 divided by V2 is equal to square root of. Just I have calculated V. Just substitute as a E1 V1 on M1. Then V remains same because same potential. That's why E1 by M1. That's why V1 by V2 is nothing but square root of. Easily you will be able to calculate. Sir, why are you given everything in the printed form and showing that one just so only speaking? See, it will take most of the time, because if we keep writing this one, we are unable to cover more amount of completely what is called by name problems in this one. We are completely taken this and explaining everything. Afterwards, we are going to solve more and more number of problems. I think you are agreeing with me. Okay. So therefore, V1 by V2 is nothing but square root of E1 divided by M1 upon E2 by M2. Okay. M2 is a denominator of a denominator. Therefore, it goes to the numerator. M1 denominator of a numerator. It comes down. Therefore, it is a square root of E1 into M2 divided by E2 into M1. Okay. So please remember, so this flower bracket result correctly. In other words, V, the velocity acquired by the particle, is directly proportional to the square of the charge associated with them. E means charge associated. Since here we are dealing with only the charges, nothing but either positive or negative. Okay, positive charge. We are nothing like positive charge here. Only when you remove one electron, that is get to be positively charged. Are we able to remove proton? Sorry, we are not able to remove proton. Remember this, please. Okay, it is positively charged, means we are not completely brought positive charges and given, means protons and given to that one. Please don't remember like that, please. Okay, we have removed one electron, therefore of electrons available is one less than compared to the number of protons available there. That's why we are saying it is positively charged. We are not adding any proton there. So please, Okay, so therefore V proportional to square root of the charge associated with that one. Since we are dealing with only the movement of electrons inside this one, that's why we have given a symbol E. Next one, V is inversely proportional to the square root of the mass associated with them. Okay, 2He4. Okay, mass number. So there is a atomic number. Atomic number means number of protons there or electrons there, because each and every substance will be consisting of same number of protons as well as electrons. That's why it is electrically neutral. That you know, I need not to tell you, but just I recalled it. Okay. So thereby easily you'll be able to understand this. Remember, so between these you'll be able to get so one problem. Okay. So next one. So here also just some relations I have given. So just to remember, okay, relation between an electric field and a potential E is equal to minus dV divided by dx. So please make sure it is dV divided by dx. A negative sign, negative potential gradient. Already I have defined it, but the some point I have to clarify: equipotential surface. There are certain regions where completely the potential remains same. So in the entire region, that surface is called by a name equipotential surface. The locus of all points which are the same potential is known by a name equipotential. But remember these points are electric force. Okay, so just let me tell you one thing here. Suppose here electric lines of force are like this. Electric lines of force are, please remember, this is called equipotential line. Not this is an equipotential line. This is a uniform electric field. Remember, all the lines of force are moving from highest potential point to the lowest potential point. Whenever you are measuring, so certainly this is the line. Suppose if I draw another line, if I call this as a, if I call this as a B, certainly, so VA is not equal to VB. Remember this forever. Remember this forever, because potential at this point certainly slightly higher compared to the potential at this point. Okay, so therefore, so potential means in the line of force, you can see this one, only the points in the same potential means along the same line you have to calculate. Then the electric lines of force are normal to the equipotential line. Normal means making 90 degree. That's what. Okay. No work is required to move a charge from one point to another point on the equipotential surface. No two equipotential surfaces intersect with each other. Near an isolated point charge, suppose you have taken an isolated point charge which is like this. Okay, so this is the point charge. How does the equipotential lines or surfaces? This one, you can see this can be called by name equipotential line. This can be called by name equipotential line. Okay, that is the way in which we are going to come across this one. So that is sphere. Potential difference between any two points in an equipotential surface is always a zero, because there is no change in the potential. Okay, so next point, you can see here are the some more we have given here. Q, the charge acquired by a body, is equal to plus or minus Ne. Then sigma, surface density of charge, charge divided by distance. Okay, sorry, area, that's equal to Q divided by 4 pi r square in case of a spherical conductor. E is equal to V by D. Okay, relation. Suppose we want to compare this. This is what I said in the previous. Now we have come across the same relation I have given. Sigma 1 divided by sigma 2. That is Q divided by 4 pi r square. So 1 is R1 square Q1. Then so Q2 R2. If you compare this one and divide it, you are going to get sigma 1 by sigma 2 is equal to Q1 by Q2 into R2 by R1. Suppose same relation I have given, sigma 1 by sigma 2 is equal to R2 by R1. Why? See the reason there. The two spheres of same potential. That means for this, Q divided by R becomes a common, means those are proportional to each other. Therefore, Q1 by Q2 can be replaced by R2 by R1. Okay, so that's why easily we can cancel. Because of that reason, we are going to get R2 by R1. Next. So there is another relation. What? So Newton's second law, F is equal to ma. Okay. Suppose a charged particle of certain mass accelerated to a potential. Mass is also there, acceleration is also there, then electric potential is also there, electric intensity is also there. A charge is carrying some magnitude. Therefore, F1 is equal to E1 into Q1 in case of electric field. In case of an electric field, F is equal to ma in case of by applying Newton's second law. So that's why F1 divided by F2 is equal to E1 into, so completely you can see the relation E1 Q1. So M1 A1. So divided by this one E2 Q2 M2 A2. Okay, so thereby easily we'll be able to calculate any quantity using this one. Any quantity means we can calculate either electric field or maybe the charge associated with this or maybe an acceleration. So happened in this one. One of that relation I have given here. So it is nothing but A1 divided by A2. That's equal to M2 into E1 into Q1, M1 E2 into Q2. Thereby we can calculate acceleration acquired by those particles. Similarly, this is already I've discussed it. So therefore, I'm going to deal now. That is V1 by V2 is equal to E1 by E2 into M2 by M1. Okay, so please remember all this. At the end, I'm going to give you all these relations. Okay, next. So here also, I think you will be able to understand this one. So already I've told you. So I'm going to completely give even the capacitor along with this. So therefore, I'm going to give the synopsis of even capacitors also. Now you remember. So the capacity of a conductor C is equal to Q divided by V. Q means charge distributed on this, the potential having it. SI unit of capacity is 1 farad is equal to 1 coulomb by 1 volt. Dimensional formula for capacity, that is m power minus 1, L power minus 2, T power 4, A power square. Okay, so that you can derive it very easily. So please remember all dimensional formula. One among them can be asked in the exam. Okay, capacity of a spherical conductor. Capacity of a spherical conductor. C is equal to 4 pi epsilon naught R. So in other words, capacity of a conductor directly proportional to the radius associated with them. This is most important. Okay, because they may going to give a two spheres. Since I have seen 2-3 problems appeared in the CET examination. Okay, C is proportional to the R. C means capacity of that conductor to hold the number of charges is directly proportional to the radius of that spherical conductor. Okay, certainly we are going to discuss some problems of the same which were given in the previous examination in the forthcoming question and answer discussion. Okay, capacitor and capacitance. The device used to store electric charges is called capacitor. It stores charge in the form of electric field. Okay. Capacity of a parallel plate capacitor, usually you remembered say epsilon A divided by D, where epsilon is an absolute permittivity of the medium, area of the plates divided by distance of separation. So that's why here. And remember, so this capacity also directly depends on the relative permittivity. So here, changing this, at least we are going to discuss not less than 10 problems. Every CET, they are asking this capacity proportional to the epsilon R. Okay, capacity of a capacitor does not depend upon the material of the plates with which it is made, because it depends on the number of storage of charges. Okay, potential difference between the plates and charges given to the plates only. It depends on so that one. If the upper plate of a parallel plate capacitor connected to a lower plate, then it becomes a very good conductor. It becomes normal. The distance of separation becomes 0. So that's why it becomes infinity. I think you will be able to understand. Your sir may be told in the class while doing the derivation corresponding to that one. So next, you can see this one. Suppose there are n parallel plates which are available. You may be heard regarding this, what is called by name farmer's problem. What is a farmer's problem? Certainly they will come across a problem with electricity. They have to pump the water for their completely. So whatever the grow or whatever they're going to grow. Okay. So whenever they want to grow means certainly they need what is called by a name. So at least a voltage of 185 to 200 minimum to run a motor. Okay. So we know that one. Now what we are supplying according to the KEB, 240 volt, 1.5 ampere. 1 to 1.5 ampere. 100% at any moment, even in completely Bangalore, if you measure this one, certainly it will not cross 220 volt. It will not cross 220 volt. Suppose if you go to the rural side, certainly it will comes out to be 180, 185 like that. Okay, even in the power line. So for the, so whatever they are giving for electricity, even so house lighting purpose, there also so much. But farmers are very clever compared to this one, but they don't know what they're using. They are saying we are using a condensers. What is the meaning of a condensers? Nothing but this one only, a n parallel placed completely a capacitor plates. How that will be? Something like this. Here is a one line means here is a one plate, here is another 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 plate here. Then are they so? No, they're going to keep another one which will be like this. Now you can see this one. This act like a parallel plate capacitor. It is a parallel plate capacitor completely. Sorry. So completely once they come across this one, certainly we can multiply. We can construct many number of capacitor. Capacitor is a device used to store the charges. Suppose if it is connected in a series, we know that one. So V is equal to V1 plus V2 plus V3, addition of potential. So that's why whatever we come across, it is get added. Suppose it is 185. Now we are providing using a condenser of something like completely 20-25 volt along with the same. If they get added, certainly the net voltage becomes the voltage which is used to lift the water using a pump. That's why they are using a word called by a name condenser. Suppose n such plates are there, how many number of capacitors we are able to construct? That's why they have given. So completely here n minus 1 capacitor. How many in number? N minus 1. There are n in number means certainly n minus 1 capacitors can be constructed using this one. That's why C is equal to n minus 1 into A epsilon naught divided by B. Okay, so that is the way they have given. Dielectric constant already I have given. So epsilon is equal to Cm divided by Ca. I need not to repeat. Dielectric constant of a metal is always an infinity. Water. So water is a pure, completely a dielectric. Do you know dielectric constant of a pure water? So dielectric constant of a pure water is equal to 80, which we are not getting anywhere. Okay, in Bangalore, it is impossible to imagine a pure water to drink. Okay, so that's why it's equal to 80. But see the definition or see the running statement. Water is not used as a dielectric since impurities dissolved in water gets ionized as soon as you are applying completely electricity and starts conducting electricity through it. Because of this, immediately you are getting a shock whenever, so every day morning a coil is immersed in a water to heat now. So there if you touch it, immediately you're going to get a shock because of this reason. So please remember for that also. If a metal slab of thickness d by 2, this is important. Okay, certainly we want to alter the capacity of this one. Okay, here is the distance I have given. So this distance is actually d by 2. Okay, the distance between the, so completely this one. Now you see a metal slab of thickness d by 2 is inserted in between the plates. Then capacity becomes, here is a air capacitor as well as a metal insertion. Now you can see it's equal to epsilon naught A divided by d minus d by 2. So this one. So then if you take an LCM and simplify, so completely once again d by 2 only. Here we are going to come across. So denominator of a denominator goes to the numerator. Therefore it becomes twice of that. That's why its capacity increases to another one. Suppose if you are introducing any other material of certain thickness T, okay, certain thickness T, then C is equal to epsilon naught A divided by D minus T plus T upon epsilon R if a material is having some dielectric constant value. Okay, so generally, so this is the equation which gives completely the change in the capacitance of that. Okay, so please move on. capacitance of a spherical capacitor. C is equal to. So I think the earlier syllabus, we have this completely what is called spherical capacitor as well as cylindrical capacitor. I think according to this, they may be deleted, but better remember this. Okay. Capacitance of a spherical capacitor, C is equal to 4 pi epsilon naught into AB by B minus A. So that is nothing but C is equal to 4 pi epsilon naught into B square. If A is nearly equal to B, then B minus A. Capacitance of a cylindrical capacitor is the equation. Anyhow, you're going to derive this one. Therefore, easily you will be able to remember that. So, most important thing, we have come across what is called by a name grouping of capacitors. Why we want to group a capacitor? We want to get a required value of a capacity. Required value means we want something like a 10 microfarad. Then how many number of capacitors which are connected in series or parallel required to do this one? Therefore, we have to study grouping. Why? We are unable to manufacture directly 10 microfarad capacitor. Suppose, just an example I'm giving. Okay. If I have only a capacitor of 1 microfarad, I'll be able to construct even 10 microfarad also. Suppose if you are connected in parallel. Okay. So if you are connected in a parallel, all positive terminals at one end, all negative plates are at the other end, called by a name parallel. So negative to positive, positive to negative, like that. If you are given series combination, you know that one. Okay. So therefore, grouping, there are two types: series grouping as well as a parallel grouping. Whenever you do series grouping, we know that one, certainly the charge remains same. In a series grouping, it will be like this. This is the positive plate, negative. Negative is connected to positive. So again, negative is connected to positive. Negative is connected to positive. Okay. So now you can see this is called by a name. So this I can call by a name C1. This I can call by a name C2. This I can call by a name C3. So sorry, I think so here. Okay. So I can connect this into the battery now. Okay, like this. Okay. So then, sorry, it is not there. So just C1, C2, C3 are the capacitors which are connected in series. Okay. Then effective capacitance, somewhere here I think we have given here. You can see this one. 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. You know that one. So really easily. So that's why easily. Then, but you remember here, whatever the charge we have come across in this one, same will be the same number of charges will be induced here. Same number positive will be here once again. Same number negative will be here. Therefore, Q is always a same in case of a series combination. So that's why V should be get added. V1 plus V2 plus V3. Okay. So this is the one. That's why here we have given. So Q1 is equal to Q2 is equal to Q3. Nothing but ratios are there here. Q1 is to Q2 is to Q3. Then potential you can see here. So V1 plus V2 plus V3. So thereby easily we can get the potential. Then so series. So here if n number of capacitors which are connected in series, then easily I can write Cs is equal to C divided by N. One relation. Suppose there are three capacitors. Let us say 1 by 2 microfarad plus 1 by 4 microfarad plus 1 by something like 8 microfarad which are connected in series. Remember, so even the effective value called by name Cs is always less than the minimum which we are connected in that. Minimum which we are connected in this one. You can calculate and see this one. 8 seems to be an LCM. Then you can calculate 4 plus 1, 5. So here 4 plus 2, 6 plus 1, 7. So 8 by 7. So certainly something like 1 point something. 1 point something is always a number which is less than 2. That's why we have given a conclusion here. We have given a conclusion here. Effective capacitance is always less than the minimum one which we are selected. The minimum one which we are selected. Here, minimum is this one, maximum is this one. It is 2 microfarad. This is 8 microfarad. Now you can see this one. CS is less than the minimum. So here, this relation, please remember, because based on this, certainly they're going to ask you some problems. V1 is to V2 is to V3. In other words, V proportional to 1 by C. Okay, potential proportional to 1 by the capacity of that one. So that's why easily you can have some problems. They are going to ask minimum one problem based on this in almost every CET. So therefore, please remember this. Okay, so let's move on. If n capacitor, each of capacity is C, are connected in series, then the effective capacitance already I have written. So that is Cs is equal to C by n. Then parallel grouping. Here remember, V potential remains same. What is that? Suppose this is the first capacitor, this is the second capacitor, this is the third capacitor. Then if they are connected in parallel means, so this is the V. Okay. So you can connect this, you can connect to this. So easily, so I can say that. So this way, if you're connected, okay, this is B, this is A, then between A and B, C1, C2, C3 are connected. This is called parallel combination. This is called parallel combination. When you are connected like this, easily, so certain, sorry, this is not connected. Yeah, connect this one. Okay, then easily the effective capacitance is given by Cp is equal to C1 plus C2 plus C3, and Cp is always greater than the highest number which you are connected. Same example you take it. So 2 microfarad, 4 microfarad, 8 microfarad. Okay, but now you see this one, 8 plus 4, 12 plus 2, 14. 14 is a number which is greater than 8. This is the highest one. So that's why here parallel combination is always higher than the highest one which we are selected in that one. Highest one among these is 2 microfarad, 4 microfarad as well as 8 microfarad. Okay, so among this seems to be the highest one. So therefore 14 is a number which is higher than 8. So that's why easily we'll be able to call that. So Cp is greater than the highest number. Then here Q1 is to Q2 is to Q3. Since completely potential remains same, so Q1, Q2, Q3, the charge acquired on each capacitor will be different. It depends on what is called by name capacity of a capacitor. That's why Q proportional to, so C. This relation you have to remember. Suppose you are completely having n number of parallel plate capacitors, then Cp is equal to n into C. So easily you'll be able to calculate that if all are identical, means same capacity. Suppose same capacitor, first connected in series, then connected in parallel, compare them. Okay, so then easily you can see this one. This is nothing but n into C. So this is nothing but C divided by n. Okay, these two gets cancelled. So n goes to the denominator of a denominator, becomes numerator. That's why it is n square. That's what the relation we have given. Cp by Cs is equal to, so n square. For two capacitors A, so in series 1 by C1 plus 1 by C2, take an LCM and do that. Then the Cs is equal to C1 into C2 divided by C1 plus C2. So this is called effective capacity in series. Similarly, when they are in parallel, so this is the value in, so parallel. Suppose you are multiplying both. Okay, Cs into Cp into Cs. Cp Cs is equal to multiplying both. Now you can see this one easily. So first one is nc into C by n. Okay, if both are different, C1 and C2 you can write. Okay, here is a C1, here is a C2, but n, how many number you are connected, n gets cancelled, therefore C1 into C2, or just I can, if both are identical, I can write just equal to C square. Okay, C square. So this is the way easily you'll be able to compare. These are called twisted results. What is the name of them? Twisted results. Same thing, you had the derivation, but so this way you should be able to remember to calculate the effective capacity, so in the combination process. So please remember regarding energy associated with them. Okay, energy is stored in a capacitor, half CV square. So you substitute for C and V. So thereby you are getting Q square by 2C and also QV divided by 2. Okay, so this way easily we'll be able to discuss for completely regrouping of a capacitors. In a regrouping, certainly we'll come across, so this one. Okay, there are two more pages which I am supposed to discuss. Then I have to start question by question. Certainly, you are going to get a help out of these discussions. There is no doubt. 100%, 2 to 3 questions will be appearing from electrostatics. So that's why easily you can bag them if you remember all these synapses correctly. All these synapses correctly. There are 2 more pages which I have to supposed to discuss it because next teacher is waiting. So therefore, I'm going to discuss this. Then tomorrow, I'm going to start. So question by question, thereby, I think you'll be able to answer as well as you can. There may be a small typographical errors. So please, if you see that one, whatever the copy which we have supplied to you, so just we are going to make the correction when we are dealing with each and every problem. So therefore, so please, so be with us. Thereby, you'll be get benefited. Suppose if you are get benefiting, please, one thing you keep it in mind. If you are satisfied, so remember, you have to call your friends to make sure the help means you are eating a feast means make sure you are also given to your friends. Okay. If I do that one, then it seems to be an advertisement. But if you do that one, it is sort of a help you can do to your friends. So that's why please make sure if you are satisfied. So with the discussion, what we are making, certainly we are going to discuss. So with very, very eagerness to make sure the students are to score good marks in this CET, forthcoming CET. So that's why. So please make sure you are sharing. So whatever you are learning to your friends, thereby they also come and join to get a benefit of this one. Thank you very much for a patient listening. I'm going through your comments. Then I'm going to discuss in tomorrow's class. Thank you very much, dear. Chaitra, thank you. Darshan, thank you. So today I'm going to wind up. Tomorrow I'm going to deal with the next part. Thank you very much.
Good afternoon, students. Yes, Abhishek is active today. So we'll be continuing with good afternoon, Shreyas. Outside it's raining. Okay. If you would join to our college, you would see a real snap of what you're seeing on the screen right now. So Let's start with today's class. Okay, so yesterday, wherever we had stopped with the problem, can you give me the answer to this? Yes, ma'am. Good afternoon. Yes. Your life, everybody's life should be bright like the sun's rays. So start with this problem. Oh, many are giving the answers to this. Okay, if A is equal to, it's a 2 cross 2 matrix, 2 minus 2 minus 2, 2. Then A to the power n is equal to 2 to the power k into A, where k is equal to, most of you gave me the answer to this. So let's check and go to the next problem. Okay. So here, there are two ways of solving this problem. One is you can, you know what is A. We can find out what is A in A squared, A to the power 3, A to the power 4 and generalize it. We wouldn't go up to A cube and A to the power 4. Okay. So what shall we do? We can find out A square by multiplying this A, this matrix to the same, and see if we can find a relation to A and A square. Yeah. Otherwise, how many of you over here to know to use the Cayley-Hamilton? How many of you have read with Cayley-Hamilton theorem? You can raise your hands. Okay. Since there is no response, this formula would be easy enough for you. Okay. This is basically a shortcut. If you want to find out A square, you can use this and try to obtain the solution. When it is a square matrix, okay, 2 cross 2, A, B, C, and D, then A square minus A plus D. That's the principal diagonal elements. We take the sum of these two multiplied with A plus determinant of A. Determinant of A is AD minus BC into the identity matrix. This is always going to give us 0. Okay, if you want to find out your A square, you can take these two terms to the right hand side and work it out. Or if you're not comfortable with that, you can directly find out what is A square and obtain the solution. I would be using this equation, and I would also suggest you people to use this because for most of the problems, it's really going to help you a lot. Okay. For the first time when you do, you might find it difficult, but when you work out with too many problems on this, this is simpler than multiplying your A with A. Clear? Now, what they've given is 2 minus 2 minus 2 and 2. This was yesterday's problem, right? I told you people to work it out. I want everyone to have your paper, pen, work it out and give me the answers. It should be a practice session. So A square is equal to A into A. That is what we are supposed to do, right? Now, what am I doing over here is I'm going to make use of this. Okay, so I'm going to make use of this equation. So A square is equal to the negative sign when it goes to the other side, it is A plus D into A minus determinant of A into I. So this is going to give us A plus D for us. 2 plus 2, this is 4. Okay. Now matrix A for us is 2 minus 2 minus 2 and 2. Minus determinant of A is going to be 2. Is that okay? Now, sorry, 2 into 2 for us is 4 minus 4 into identity matrix. Simplify this. A square, this is equal to, this is 0 for us. Okay, 4 is going to get multiplied to each element. So 8 minus 8 minus 8, 8. Now here, this is the expression what we have. Let us see whether we can write this matrix in the expression what they have given to us. We should have our matrix A. So if we should have a matrix A, then we're supposed to have 2. So to have 2, let me write down this 8 to be as 2 into 4, all the elements. So 4 is a common term. Let me take out this 4 outside. We have 2 minus 2, okay, minus 2 and 2. Now, this can also be written as 4 can be written as 2 squared into 2 minus 2 minus 2 and 2. Clear? Now, I want you people to take these two. We are not going to move to the third a cube, a power 4 and all. We try to generalize with these two. The first one what we have, this can also be written as, we should have this matrix A over here, right? So I'm going to have that matrix A as it is. 2 to the power k, I can write this to be as 2 to the power 0. Anything to the power 0 is 1 for us. Now, just check with the expressions what we have towards the right hand side. Okay, here and here. So from these two, we try to generalize this and generalize this. This is our matrix A. Is that right? I'm trying to write to my right hand side. And left hand side, this is A to the power 1. This is A to the power 2. Like after 1, we have 2. Since we are generalizing, this is going to be A to the power n, which is equal to, now, this is 2 to the power 0, 2 to the power 2. So we have even terms over here. 2, 4, try with the next one if you have time. Finally, okay. So 2, 4, 6. These sequence of numbers, this can be written as 2n minus 2, right? This 2, the base whatever we have is a common term. So let me write that 2 over here. And this k for us is 2n minus 2. They've asked us what is k value. So k is 2. You can take out the common factor over here and we have n minus 1. Good. Most of you gave the answer. So let's move to the next question. If a is equal to 3 minus 4, 1 minus 1, then a to the power n is equal to. Okay. I've been telling you, use this expression when you want to find out a squared. It would really be easy for you to find out. Now, out of these 4 options what you have, they are asking us which is going to satisfy for a to the power n. And to find out for a to the power n here, let me find out what would be a squared. And to find out a squared, I'm going to make use of this expression and work it out. Now, if you just see this equation here, the degree of a is Chandra Prasad will come back to your 13th question at the last. He just told like you could not understand. Try to understand this. It is very much similar to the previous one. If not, we'll solve that problem. Okay. Now, this expression what you see, the degree of a is decreasing. A to the power 0, a to the power 1, and this is a to the power 0. There is nothing to memorize here. Alternatively, positive, negative, plus, minus, plus. Now, coefficient of a square is 1. Coefficient of a is a plus d. What is this a plus d? This is 3 and minus 1. And determinant of a, you people know how to work it out. Very good, Saujanya. Your answer is right. Okay. So here, I'm going to use this expression. A plus d will be 3 minus 1. This is 2 into 3 minus 4, 1 minus 1. Okay. Minus. Now, determinant of this is going to be minus 3 plus 1. Minus 3 plus 4. That is nothing but 1 for us. So, solve this. This is 6 minus 8. Okay, 1 into I. Then this is 2 minus 2 minus, it's an identity matrix, 1, 0, 0, 1. So what do we get? This is 5 minus 8. 2 minus 0 is 2. Minus 2 minus 1 is minus 3. Please check with this. Okay, what are you checking? We have found out what is a square over here. They've asked for a power n. Just take n to be as 2 in these expression and check out for each element. First, I would be doing for the first element for all the three matrices. Good, Ritik. N is equal to 2. 2 into 2, 4 plus 1 is 5. Okay, we are supposed to get 5. This is 5. 2 into 2 is 4 plus 1 is 5. 2 into 2 is 4 plus 1 is 5. All the three are satisfying with the first element. Let's move to the second one. Okay, we have to check with the second one. Now n is equal to 2. So 4 into 2 is minus 8, which is satisfying. Check with the next one. Minus 6 minus 1. So it's not with minus 8. We can live this. Come to this one. Even this matrix, it's not going to satisfy because it is minus 6. So our options are only with 1 and D. You simply can't tick your 1. You have to check with all the 4 elements. Now the next one is 2. N is 2. So third element is right. Fourth element is 1 minus 4. That is equal to 3. Very good. Kishore, Rachna. Many of you gave the answer. Okay, Rachna is asking, how did you take or why did you take n to be as 2? Now, these values, what they have given to us, the options what has been given to us are a to the power n. Is that okay? These values are a to the power n. And what we have found out over here is a square. Now, if I take this n to be as 2 in these options, if it is going to satisfy, then that particular matrix is right for us. So that was the reason we just took this n to be as 2 in all the matrices and checked. Okay, hope so I have reached you, Rachna. 15th one. If A is equal to cos theta sin theta minus sin theta cos theta, then A power n is equal to, option A is n cos theta, n sin theta, minus n sin theta, n cos theta. B is cos theta sin theta minus sin theta cos theta. C is cos n theta sin n theta minus sin n theta cos n theta. D is 1, 0, 0, 1. This would be done in a similar format. I'm just trying to use the same formula. Check, check. How come, Bhuvan, this time you have done the mistake? Check with the answer. Now here, if we use the same formula with what we did in the previous one, same like with the previous one, a square, check Mukti, no. Why are people giving me the wrong answers? Check. A square is a plus d into a minus determinant of a into I. Okay. A plus d for us is cos theta is, this is 2 cos theta. Actually, for this problem, working out by this method, you might find it lengthier. Otherwise, just doing with the ordinary method itself is easy. Multiply a into a and try to get the answer. This is cos theta, sin theta, minus sin theta, cos theta. Determinant of a, cos square theta plus sin square theta into identity matrix, that is 1, 0, 0, 1. Fine. So here a square, this is equal to 2 cos square theta, 2 cos theta sin theta, 2 minus 2 cos theta sin theta. Very good. Many are giving with the answers. Yes, Tarun, you're right. Then 2 cos square theta. Okay. Now this should get subtracted with cos square theta plus sin square theta for us is 1. So we are going to have with our identity matrix. So what is this? 2 cos square theta minus 1. Okay. Now we are going to subtract this 2 cos theta sin theta to 0. So this is 2 cos theta sin theta. Okay. Minus 2 cos theta sin theta. And the last one is 2 cos square theta. How did you get 2 cos theta? See here. According to the formula, what do? These two are going to get added up. Cos theta plus cos theta is 2 cos theta. Many had it out. Tarun, Chaitra. Cos theta is 2 cos theta. That is how we get. Okay. Now complete this. What's the answer to this? Since there is no space, I would use over here. 2 cos square theta minus 1 is cos 2 theta. 2 cos theta sin theta can be written as sin 2 theta. This can be written as minus sin 2 theta. I made a mistake here. I left out with this minus 1. So this is cos 2 theta. So what do? Take n to be as this is 2. They've asked for a power n. Now when n is equal to 2, check with these 4 options. D is left out. Okay. C, B again, we can't consider it because 2 is missing over here. N we don't have over here. So option is C. Okay. So I've been using the same formula here. Okay. 16th one. This is a square matrix for us. Thank you, Chavan. This is a square matrix and they've asked us a to the power 4 and the answer to this. Please note down 8. When you have a 3 cross 3, we can't use the previous formula what we had. That expression is only used for a 2 cross 2 matrix. If it is a 3 cross 3, you people don't have a choice. What are you supposed to do? You have to multiply the given square matrix again to itself, which is going to give us a square. Okay, start doing it. No, Tarun, check with the answer. I want you to be active, but I want you people to work. Just see the answers. Answers are not right. 0, 0, 1, 0, 1, 0, 1, 0, 0. Good, Shreyas. 0, 0, 1, 0, 1, 0, 1, 0, 0. Student who are not answering, I want you people, I know many of them, you'll be working out, okay? But you would hesitate to give the answers. You don't have to unmute yourself. You have to just put the answers onto the chat box. So what is this? 0 into 0 is 0. 0 into 0 is 0. 1 into 1, this is 1. Next. Again, what are we going to do? We're going to consider this row and multiply with the second column of the second matrix. So 0 into 0 is 0. 0 into 1 is 0. 1 into 0, this is 0. The same row, we're going to go to the next one, next column. Okay, so this is 0, 0, 0. Let's move to the second row of the first matrix to the first column of the second matrix. So this is 0, right? 1 into 0 is 0. 0 into 1, this is 0 for us. I think I made a mistake.
The mid, it should be 1, ma'am. 0, 1, 0.
0, 1, 0. Very good. Okay, it is 0, 1, 0. Fine. Now, let's move to the third one. I just wrote down multiplying with this When you multiply the second row of the first matrix to the second row of the second matrix, you get this to be as 1. Second row of the first matrix to the third row. So 0 into 1 is 0, this is 0, and this is 0. Finally, let's go with the third row. So this is going to get multiplied with the first column of the second matrix. So this is giving a 0. Again, this row getting multiplied with the second column of the second matrix. 0, 0, 0. And finally, this is 0. 1 into 4 is 1. The next two is 0. This is an identity matrix for us. So A square, what we have over here, is an identity matrix. So the even powers, what should be A to the power 4 then?
A to the power of 4.
Identity. If you're going to get identity, what would be the next one? You're not going to, your I is just getting multiplied once again, right? You're going to get back your I itself.
It's again into A square, ma'am.
Very good. It's again into A square. Your A to the power 4 would be A square into A square. That was a very nice answer. Okay. So identity matrix, your answer is C. Good. Good, Murli. Murli also had the same answer. So moving on to the next one. 17th one. If A and B are square matrices of order n such that A square minus B square is equal to A minus B into A plus B, then which of the following will be true? First one, either of A or B is a zero matrix. B is A is equal to B. C is AB is equal to BA. And D is either of A or B is an identity matrix. So this is one of the question paper problem. Okay, I thought this would be an immediate answer. Okay, Bhuvan says it is C. Right. Now, when you just see the question, this would really confuse for so many of them. Some would say A. Okay, Mukti is saying A. Now, it's not possible because they have given us a general case. They have given A and B, and they haven't specified what is A and what is B. Okay. Since this is a general case, this might satisfy, and our answer also should be in terms of the general case for the general case. Okay. So what do we do over there? What do we do? Here, let us consider with the data given to us. They have given us A square minus B square. This is equal to A minus B into A plus B. Clear? Now, to our right hand side, we can simplify this, and this can be written as A square plus AB minus BA minus
B square.
Now this A square and B square, this would get cancelled, and we are going to have 0, which is equal to AB minus BA. Or over here, AB is equal to BA. Tarun, yes, you're right. You've pressed so many times. Okay, good. Your answer is right. Even Shravani, good. Tejas, son. Shreyas, I would unmute you later finally because I couldn't get the question with what you told. Ma'am, when you don't get any logic in maths, what do you do? Okay, to this we'll answer at the end. Because right now, today would be the last matrices class. I want to work out as number of problems. Okay, trying to cover with all matrices. Determinants will be done by the other person. So I want to cover with everything for today's class. Finally, you can unmute and you can ask me. Okay, yeah. Now, next one, if A is equal to, I wouldn't read this matrix. You can see how big it is. Please have a look onto this. Let me do it. A equals 1 by pi into, it's a 2, screen sharing is off. Is this
No, ma'am.
visible?
No, ma'am. It's visible,
It's
ma'am.
visible, ma'am.
Okay, thank you. Now, sine inverse of x pi. Second element is tan inverse of x divided by pi. Third element of matrix A is sine inverse of x divided by pi. Fourth element is cot inverse of x by pi, x into pi. Then the next matrix B for us is 1 by pi into minus cos inverse of x pi, tan inverse of x divided by pi. Third one is sine inverse of x by pi. Fourth is minus tan inverse of x by pi, x into pi. We should take the difference, A minus B. These are the options. These are the options. Oh, there are so many mistakes. Check. I thought without working out, you people would have given me, you're going to give me the answer. Inverse trigonometric function. Sine inverse of x plus cos inverse of x. This is equal to pi by 2. Okay. So we have to take the difference between these two matrices. 1 by pi is a common factor for us. So let us take out 1 by pi outside. Now, when we subtract this, there's a negative sign for the first element. Minus into minus would become plus for us. So sine inverse of x pi, this is one complete angle. Okay. Plus cos inverse of x pi. The next term is tan inverse of x divided by pi minus tan inverse of x by pi. I expected this to be a very good answer, out from everyone, mass answer, but lots of mistakes from you people. Try it out. Sine inverse by pi minus sine inverse of x by pi. And finally, the last element, cot inverse of x pi plus tan inverse of x pi. Okay. Now this is the identity what you people had learned in your first PUC. Inverse trigonometric function. You're supposed to use that inverse trigonometric function over here. This is pi by 2. This is 0. This is 0. This is pi by 2. Yeah. We can take out this pi by 2 outside as a common factor. 1, 0, 0, 1. This is an identity matrix. So this is nothing but 1 by 2 into pi. Tarun, what happened? Answer is D. Doesn't matter, please do mistakes here, but your examination, none of you should do a mistake. As I've told you, let us have this class as a practice session. Fine. Next one. Next problem. If matrix A, it's a 2 cross 2 matrix, what they've given us, where Aij is equal to, it's a condition. Here, when I is not equal to j, a value is 1. And when I is equal to j, value is 0. Now, they're asking us what would be a squared to this? What would be a squared to this? As I've told you, I would make use of the formula what we had, what we did initially, the first 3 or 4 problems, same formula. But to this problem, the first step is you're supposed to find out what is this A. Use the condition and try to find out what is A. 2 cross 2 matrix. So the first element, I'm going to take it as first row, first column. Second element as first row, second column. Third element as second row, first column. And fourth element to be as second row, second column. Okay. Now let's come to the condition. When I equal to j here, I is equal to j here, I is equal to j. This would give us 0. When I is not equal to j, it is 1. So this is the matrix what we had. We did a 3 cross 3 matrix there. We have a 2 cross 2. Very good. All of you have given the right answer. Okay. So let's do with this. A square 0. I would apply the formula. A plus D into A minus AD minus BC. This is the determinant into I. So A plus D is 0 for us. So 0 minus this is 1 into I. So what is this? Minus into minus is plus I. We did not multiply. So this is the beauty of the equation what we have for a 2 cross 2 matrix. Okay. So everyone, very good, very good, very good. The same students are literally typing, so I wouldn't take out their name. Tarun, Sham. So all the time I wouldn't keep on telling good for you people. I want even the others also to come up like this. 20th. If A is a square matrix such that A square equals A, then Tarun, I haven't given the option. How can you say the answer is A? A is a square matrix such that A square equals A, then I plus A whole cube minus 7A is equal to. Let's see whether Tarun is right. Start solving this. Okay. So I plus A whole cube. I plus A whole cube minus 7A. Okay. Let me use everyone are right. Who and all answered for this problem, you people are right. A plus B whole cube I cube plus A cube plus 3I square A plus 3I A square minus 7A. Okay. Now identity matrix, this is going to be, you multiply it 3 times, you're going to get it as I itself. A cube, let us rewrite this to be as A square into A. They have given us a condition over here saying A square is equal to A for us. Again, A square is going to be A. So A cube can be replaced by A. Identity matrix, when you multiply to a given matrix, we get back the given matrix. So this is 3A. And here, A square can be replaced by A. Ujjwal, check. Minus 7A. So what's the answer? 3 plus 3, 6 plus 1, 7. 7 minus 7A, 7A. This is going to get cancelled. So I suppose Ujjwal was the first person to give the answer to be as I. And that's nothing but C. How can you see my PDF? No chance. 21. If A is equal to 5, 3, minus 1, minus 2, then the value of A square minus 3A is equal to, look, you people are going to waste time to this problem if you don't know the equation what I had given to you. If you know that equation, this is going to be much simpler for you to solve and get the solution to it. You might get a correct answer, but when you would multiply your A to A, whatever answer you get, then subtract with 3A, that's going to take lots of time. Okay, these are the options what we have. Now, we know this expression. Is that right? We'll try to make use of this expression and solve the problem. So here, it starts from a second degree. That's the main reason we're going to use this equation, A square. Now, when we add the principal diagonal elements, 5 minus 2 for us is 3. And you can see here, it's 3A for us. Okay. And determinant over here, this is going to be minus 10 plus 3, this is equal to 0. So a square minus 3a, this is equal to, Charan, I don't want you to do anything. If you can just stop it, it would be better. Minus 7. Okay. Sorry, this is going to be plus 7. We are taking it to the right hand side. Take it to the right hand side. They've asked us a square minus 3a. The answer to this is 7i. This hardly took a minute for us to get the solution. But if you try to multiply this a with a, you have to go for matrix multiplication. That value should get subtracted with 3a. You're going to get an answer as 7i, but the time duration what you would take would be more. Okay, next one. Good. If A and B are two square matrices of the same order such that AB equals B and BA equals A, then A square plus B square is always equal to 2AB, 2BA, A plus B. Most of them to this, they're going to give the option to be as A. Most of them. Very good, Rachna. Good, Shravani. Now, here, A square plus B square. This can be written as A square. Let us write that to be as A into A. B square, we'll write it as B into B. Okay. They have given A to be as B into A. So I'm going to replace this A by B into A plus this B I'm going to replace by A into B. Now it is a square matrix. If it is a square matrix, it would satisfy with the associative property of multiplication. So we can write this to be as A, B, associative property into A, okay, plus B, A into B. Some of you would be fast, but there are few students who would really want the explanation. So I would request you to be ready with the next one. Good, your answers are right, but just wait to this. So AB, what's for the next step? AB is nothing but B for us. And BA is A. Okay. BA, they've given that to be as A. And AB, they've given as B. So A square plus B square is A into B. Option is D. Okay, option is D. So next one. A is 3, 2, 1, 1. We have an equation over here. A square plus XA plus Y into I equal to 0 for XY is equal to. So most of them who wouldn't have this key point, who don't know this equation, they would really find difficult to solve with this problem with the ordinary method. Very good, Mukti. Okay. So how do we work it out? This is one of the question paper problem. Check. One of the question paper problem. How do we solve this? As I've told you, we are going to make use of the same expression what we had for the previous equation. When you have a square matrix of order 2 cross 2, okay, and we want A square, or if you find A square in your equation, then we make use of this equation and try to obtain the solution. Okay. Now this matrix for us is 3, 2, 1, 1. So what do we have? When I apply to this, we're going to have A square. 3 plus 1 is 4A plus, now determinant of this 3 minus 2 is 1 into the identity matrix. This is equal to 0. Now what you people are going to do over here is, this is the equation what they have given is a square plus x into a plus y into I. This is equal to 0. So if you know this equation, it would be easy for you to connect. Y is equal to 1. And what is x for us? There is plus and there is minus. Be careful. X is equal to minus 4. Y is equal to 1. And Mukti was the first person to answer to this. So option is C, minus 4, 1. Clear? So moving on to the next one. If A is equal to 1 minus 3, 2, K, and we have the same expression here. A square minus 4A, that plus 10I, this is equal to A. Then K is equal to, I want you people to please make a correction in the question. This is A square minus 5A plus 10I is equal to A. Then K is equal to, check with the values. This is also a question paper problem. Okay. So what do? They have given us I. Sorry, they have given us A. 1 minus 3, 2 and K. And if we apply this matrix, or we write it down in the equation format, we are going to have it as A square plus, sorry, it's minus, because alternative minus K plus 1 into A plus determinant value. So this is K. Okay, minus into minus is plus 6 into I. This is equal to 0. Now what have they given us? What have they given us? We have A square. Is that right? Minus 5A plus 10I. There's a mistake in this. This is 0. Please make the correction in this question. That is equal to 0. So this is equal to 0. What are we going to do? Equate with these two. K plus 1 is equal to 5. Okay. K is equal to 4. Moving on to the next one. K plus 6 is equal to 10, or K is equal to 4. Look, A, B, both the options are not possible. D says 1 or 4. We can't consider this D. We have 4 here, but we can't take this D because 1 is not going to satisfy. Okay. So the only option what is left out for us is 4 and not 1. So the answer to this is C. Yeah. Next problem. If A is equal to, it's a 2 cross 2 matrix, minus 1, 2, 3, minus 4, then element A21 of A square S. Okay. Now, this element is A11, this element is A12, this is A21, and this is A22. Okay. Now you can go to the formula what we used, but we should just find out one element. So instead of using that formula, we'll go to the ordinary method with what we know. What is that? If we want A square, we have to multiply A twice, right? Minus 1, 2, 3, minus 4. Okay. And that should get multiplied again with minus 1, 2, 3, minus 4. Now we are supposed to get, when we multiply this, A21 comes to this point. This is the answer what we're supposed to get. And to this element, what do? How can we get that? Let us consider the second row of the first matrix and we'll multiply that to the first column of the second matrix. So -3, okay, -3, -12, and the answer to this is, I don't want you people to get distracted with Tarun. He is jobless. He doesn't have any seriousness. Live. Okay, don't concentrate on to him. You have to just neglect the persons who are not serious enough. We should not get disturbed because of him. See, if you work out with the problem, see the answer. Okay, that will increase your confidence level. Right? Now, what's the answer to this? It's -15. So the answer to this is -50. Clear? So the next question. We have two matrices here. I mean, it doesn't look so simple. It is 3A plus 4B dash. And it's 2 cross 3 matrix. And the other matrix, what we have is 3 cross 2 matrix. And it's 2B minus 3A transpose. And they're asking us to find out what is B. There's no shortcut to this. It's a 2019 paper and you people have to work out by the ordinary method. Okay. How do we do to this? Since the space is less, here what am I going to do is, I would take the first matrix, okay, take the transpose of it. So when I would take the transpose of it, because when the order of these two are same, addition or subtraction would be easy for us. Now to do that, we are going to change the order of this particular matrix. So this is going to be written as 7, 0, minus 10, 6, 17, 31. Clear? Now to this matrix, what am I going to do? So this is taken as the first matrix and this is taken as the second matrix. Just check out with the left hand side here. You have 2B, you have 3A. Before that, simplify this. This can be written as, okay, left hand side would be 3A dash plus 4B. Now I want you people to see the left hand side of equation 1 to the left hand side of equation 2. You have 4B, you have 2B here. Okay, this is minus 3A dash and this is plus 3A dash. So this 3A dash, when we are going to add with these two expressions, are going to get cancelled. So let us add our first and the second equation. 3A dash gets cancelled. 4 plus 2 is 6B. And this is going to give us 7 minus 1 is 6. Okay. Then 0 plus 8, this is 18. The next value is minus 6, 6, 12, and 24. Okay. Added this matrix to the second matrix. We have 6B. Finding out B is not at all difficult for us. You have to just divide by 6. And when you divide by 6, this is going to give us 1, 3, minus 1, 1, 2, and 4. So the matrix which is matching to that is good, good. When all are answered, you people are right. The answer is B. We are left out with 2 minutes. I would just take with the next few more minutes and I would be fast to these 3 slides because these are the topics which is left out and I don't want to conclude without this. Symmetric matrix. Okay, and you have to know what is Q-symmetric matrix. So instead of these words, let me explain with an example here. Symmetric matrix means if they give us a matrix A that matrix should be equal to its transpose. Clear? So 1, 2, 3. Let me have 4 and 6 here. So this is 3, 2, 5 and 5. Okay. A is equal to A transpose. When we interchange the rows and columns, then if we get back the same matrix, we call that to be as symmetric. Or in the other way around, if you fold this diagonally from here, if you just close this towards the principal diagonal elements, okay, you people know, if you have a dot of paper and close it, it should be a mirror image. So just see here, this 2 and 2 over here is the same. You have 3 and 3 over here, 5 and 5 over here. This is symmetric matrix. Skew symmetric matrix, this is defined as A should be equal to minus A transpose. Or the other way around, you can also take the negative to the other side. And example to this, I'm considering a 3 cross 3 matrix so that it would be easy for you to connect to the higher matrices. The principal diagonal elements should be 0. It is a must in skew symmetric matrix. If I have 2 here, I should not just have 2, I should have the other sign. Okay, it's a positive integer means this should be a negative integer, minus 2. If this is 3, then this has to be minus 3. If this is 5, this should be minus 5. We call this to be as skew symmetric matrix. Okay. Now there are few properties with this skew symmetric matrix. Okay. First one, for a square matrix, you people can see your books, you would have worked out lots of problems, but this would help for the rest of the problems what we would do for today's class. For a square matrix with previous slide. Hold on, students. Okay, I'm supposed to wind up the session it seems since, yeah, I'll do it. PDF would be sent to you through the WhatsApp group. And let me see, if possible for the next half an hour with whatever I have left out, if there is time, I would work it out for you people. We'll try to complete this. Thanks a lot. You people were very active.
Thank
During
you.
yeah, this sort of a time, there's so much of interest in you. Keep the same zeal. Okay. Be happy, be safe. Take your examination very well. Few more days. These days are very, very important. Okay.
Ma'am, can we get this PDF, ma'am?
Sure. Yeah.
Thank you, ma'am.
Yeah.
Thank
Bye.
you, ma'am.
Yeah, yeah. All of you, thank you. Take care. Bye.
Thank
Yeah.
you, ma'am.
Yeah. Bye.
Basaraju sir, am I audible?
Shall I start, Vinay?
Sir?
Share ಮಾಡಲಾ?
ಮಾಡಿ ಸರ್, ಪ್ರೆಸೆಂಟರ್ ಮಾಡಿದ್ದೀವಿ ಸರ್.
Okay.
Good evening, dear students. Today we will, last time when we met, I discussed with you the one chapter from organic chemistry, basics of organic. Today, I'm going to discuss with you, here I discussed a few important aspects of basics of organic. And we solved some problems, and the notes synopsis of the basics of organic chemistry as well as the question and answers notes I shared in the WhatsApp group also. So today I discuss with you about two chapters from physical chemistry. One is electrochemistry and solid state. So what we do here is, out of these two chapters, the most important topics we discuss in bit detail, and remaining topics we will try to cover up. We'll cover up while discussing the questions in tomorrow's class. So all of you know that electrochemistry is the branch of chemistry which deals with the interconversion of chemical and electrical energies. And you know that the instrument which is being used to convert chemical energy into electrical energy is what we call as electrochemical cell. And the instrument which is being used to convert electrical energy into chemical energy is what is called as electrolytics. Since all of you know this, right? So in an electrochemical cell, we convert chemical energy into electrical energy by the virtue of redox reactions. This electrochemical cell is also called as galvanic cell, and a primitive galvanic cell is also called as Daniell cell. Whereas in the electrolytic cell, what we do, by passing the electric current, we carry out chemical reactions, and that is what is called as the instrument, or is what is called as electrolytic cell. And by using these two kinds of the instruments, we carry out the interconversion of chemical and electrical energy. The entire study of the various things which are being involved in the interconversion of chemical and electrical energies is what we call as electrochemistry. And from the point of your syllabus, the entire electrochemistry, what you studied in electrochemistry is, one is you studied about electrochemical cells. And in while studying about electrochemical cells, you come across what is called as electrode potential, each and every electrode having its own potential. And while coming across electropotential, we come across one more important concept called as electrochemical series. There we also come across, in continuation of that, we come across Nernst equation to find out the electrode potential of single electrodes, as well as the Nernst equation for potential of a cell. And we come across another concept called as electrolysis. Electrolysis, as I told you, it is carry out the reactivity decomposition reactions. That is what is called electrolysis. Under electrolysis, we come across Faraday's laws of electrolysis, Kohlrausch, and conductance of the electrolytic solutions upon increasing the dilution, and different kinds of electrochemicals. Again, we come across one more important concept called as batteries and the fuel cells. And again, one more concept which is very important from the point of view of economy of a country and development of the country. From point of view of examination, a few questions are being asked. That is corrosion. Corrosion is also electrochemical phenomenon. So these are the few important topics which are being covered in this chapter called as electrochemistry. And out of these topics, the most important topics where the tricky questions, some twisting kind of the questions can be asked, are that where those kinds of the questions can be asked from electrochemical cells part and potential and electrochemical series part. In the first two parts, some tricky questions and a more number of questions can be asked. That there is a scope for asking different kinds of questions from these two parts. And from electrolysis part, some problem-based questions can be asked here. Electrochemical part also, some problems can be asked based on Nernst equation. And electrolysis part, the problem-based questions based on Faraday's law, based on Kohlrausch law, and based on conductance like specific conductance, molar conductance can be asked. And completely theory-based questions are being asked from batteries, fuel cells, and corrosion. And in this session, dear students, we try to concentrate mainly on electrochemical cells, electrode potentials, and electrochemical series. And the remaining topics we cover up while discussing the questions in tomorrow's class. Okay. So in the electrochemical cell, we try to understand the electrochemical cell by taking the example of
ಚಿರರಾಜ್ ಬಸವರಾಜ್ ಸರ್ ನಿಮ್ಮ ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ಸರ್.
1 second. ಈಗ ಸರಿಯಾಗಿದೆಯಾ? Now the voice is clear?
Yes, sir.
Okay. Okay. So we'll try to understand the working of the electrochemical cell by taking the example of primitive galvanic cell, that is zinc copper galvanic cell. So where zinc rod is dipped in zinc nitrate solution, or we can dip in zinc sulfate also, any salt solution of the zinc, and copper dipped in copper nitrate solution. Whenever we do so, whenever we take this kind of the cell, generally what happens is, we'll see, I'll write the entire. So when you take zinc in zinc nitrate solution, zinc rod dipped in zinc nitrate solution, copper rod dipped in copper sulfates, copper nitrate solution, and you are connecting zinc rod and copper rod through by using a connecting wire, and connecting two off cells by using the salt bridge. Salt bridge is containing sodium nitrate in agar-agar gel. So the moment you do so, what happens? Connecting zinc electrode with the copper electrode. Zinc electrode is the one where zinc rod is dipped in zinc nitrate. Copper electrode is the one where copper rod is dipped in copper nitrate. The moment you do so, what happens? The zinc electrode acts as anode and copper electrode acts as cathode, because the zinc electrode, the potential of the zinc electrode is lesser than the copper electrode. So therefore, whenever any two electrodes are connected like this, out of these two electrodes, electrode having lesser potential becomes anodic in nature, and the electrode which is having the higher potential becomes cathodic in nature. The moment it is being done, what happens? At the zinc electrode, oxidation takes place, and at the copper electrode, reduction takes place. At the zinc electrode, what happens? The zinc atoms present in the zinc rod undergo oxidation, forming zinc ions along with the release of electrons. These zinc ions will be entering into the solution like this. Will be entering into the solution, and electrons enter the circuit, move through the circuit, and reach the cathode. At the cathode, the copper ions present in the solution, because copper rod is dipped in copper nitrate solution. Copper nitrate means copper nitrate is dissociated, providing copper ions and nitrate ions. And the copper ions present in the solution move towards the copper rod, and they accept the electrons coming from the anode, and they get reduced to form copper atoms, and these atoms get deposited on the surface of the cathode, on the surface of the cathode. And another thing is, as you are observing here, when two electrodes are connected externally through the circuit, internally through the salt bridge, at the zinc electrode, oxidation takes place, reduction takes place. When oxidation occurs at the cathode, what happens? Oxidation occurs at the anode. What happens? The zinc rod present in the zinc electrode, they undergo oxidation, forming zinc ions, and these zinc ions entering into the solution. Thereby, in this solution, number of zinc ions become more than the number of nitrate ions, or number of cations become more than the number of anions. Therefore, to maintain the ionic balance, nitrate ions will be pushed to the anodic compartment. Cathodic compartment, copper ions move towards the electrode, where they accept the electrons coming from the anode, and they get reduced to form copper atoms. These copper atoms getting deposited on the surface of the cathode. As a result of that, number of copper ions become less than the number of nitrate ions, or number of cations become less than the number of anions. Therefore, from the salt bridge, the sodium towards the cathodic compartment. Thereby, ionic balance will be maintained. Thereby, the continuation of the reaction will be taken care. Therefore, the role of the salt bridge is mainly to maintain the ionic balance. And here, the anode, zinc is acting as anode, it is assigned with the negative sign, because in the case of the chemical cell like this, oxidation at the anode, oxidation is associated with the release of negatively charged electrons. Therefore, anode is always assigned with the negative sign, whereas the cathode is assigned with the positive sign, because the negatively charged electrons are consumed here, and copper ions, positively charged copper ions, are moving towards the electrode. Therefore, it's assigned with the positive sign. So this point, remember clearly, in the case of electrochemical cell or galvanic cell or Daniell cell, anode is the one where oxidation takes place, negative sign. Cathode is the one where reduction takes place, and it is assigned with the positive sign. Whereas in the case of electrolytic cell, what happens is anode is the one which is connected to the positive terminal of the battery. Therefore, it is always assigned with the positive sign. And the cathode is the one which is connected to the negative terminal of the battery, and it is therefore assigned with the negative sign. So therefore, there is a clear difference between the anode and the cathode when we compare electrochemical cell and the electrolytic cell. This point you have to remember. Okay. Now, in the case of this electrochemical cell, as you are observing here, at the anode, zinc electrode, zinc rod continuously undergoing oxidation, thereby zinc atoms present in the zinc rod undergoing oxidation, becoming zinc ions. So therefore, gradually thickness of the zinc rod decreases. And here copper ions from the bulk of the solution move towards the copper rod, they get reduced to become copper atoms, and they get deposited. Therefore, thickness of the copper rod gradually increases. So therefore, gradually when the reaction is occurring, if you keep any electronic gas, so when the oxidation is occurring at the anode and reduction is occurring at the cathode, there is a continuous flow of electrons from anode towards the cathode, and the flow of electrons is nothing but flow of charges. Flow of charges is nothing but, we can say, flow of current. Therefore, we say because of the oxidation and reduction at anode and the cathode respectively, there is a flow of electrons. Therefore, we say there is a generation of current. So this is how the redox reaction occurring at electrodes, there is a generation of current. This is how an electrochemical cell is a device used to convert chemical into electrical energy by virtue of the redox reactions. Suppose if you keep a small bulb here, which can be generated out of this cell, then the bulb starts glowing. Any small electronic gadget, if you keep here, that starts working. So this is how we can say electrochemical energy becoming electrical energy by the virtue of the redox reactions. So this is how any electrochemical cell works, dear students. Galvanic cell, it's also called as galvanic cell or the Daniell cell. Galvanic cell or the Daniell cell. Okay, and this galvanic cell, if you combine two or more galvanic cells, that is what we call as a battery. For example, imagine a single galvanic cell produces 2 volts. Then suppose for a particular purpose you want 6 volts. Then what you will be doing? You will be combining 3 galvanic cells together. The combination of those 3 galvanic cells, we call it as a battery. Therefore, a battery is a device which is a combination of 2 or more galvanic cells, which can convert chemical energy into electrical energy. Chemical energy into electrical energy. So when they come back to this electrochemical cell, this is how any electrochemical cell works. Whenever you combine any 2 electrodes, one of the electrodes having lower potential becomes anodic, other electrode having higher potential becomes cathodic. And how to represent any galvanic cell, how to represent the cell reaction occurring in a galvanic cell. See here, in the case of this particular this particular example of copper and zinc galvanic cell or the electrochemical cell, at the zinc oxidation takes place where zinc becomes zinc 2 plus along with the release of electrons. Electrons reach the cathode. At the cathode, copper ions accept the electrons becoming copper atom. So therefore, this is the off cell reaction occurring at the cathode. This is the off cell reaction occurring at the anode. And the overall reaction, we write it as overall cell reaction, we write like this. That is zinc becoming zinc 2 plus, zinc becoming zinc 2 plus by undergoing oxidation, and copper 2 plus ions becoming copper atom by accepting 2 electrons. Therefore, overall cell reaction can be written like this, and the cell representation it has to be written like this. That is, at the anode, while writing the cell representation, remember, and all of you will be knowing this, that is, anode is written first, followed by the cathode, and anode is written by writing the metal atom first, followed by the metal ion. It is indicating that the zinc is becoming zinc ion upon oxidation, because at the anode oxidation takes place, thereby a neutral metal atom become metal ion, and the single vertical line represents the phase change. And the cathode is represented by writing at the right hand side, where cathode is written by writing the metal ion first, followed by the metal atom, because metal ion become metal atom upon reduction. And anode and cathode are represented by separated by double vertical line, indicating the salt bridge. So suppose sometimes in the examination, they just if they just given it as zinc bar zinc 2 plus, it is the anodic half cell. Copper 2 plus bar copper, it is the cathodic half cell. Therefore, you can write the complete cell representation like this, or you can also write the half cell representation just by writing anodic half cell or by writing the cathodic half cell. So therefore, whenever you are dealing with any electrochemical cell, how the electrochemical cell works, what happens at the anode, what happens at the cathode, and what is the overall reaction occurring, and how to represent the overall cell. So in this case, what we have understood here is, we have understood that every electrode. So when we come across electrochemical cell, by taking the example of copper and zinc electrodes, we came to know that there are plenty of electrodes, and each and every electrode is having its own potential. Therefore, whenever we connect any two electrodes, a electrochemical cell is going to be formed. Out of those two electrodes, the electrode which is having the lower potential becomes anodic in nature and undergoes oxidation, and the electrode which is having the higher potential becoming cathode and undergoes reduction. But therefore, the point is, we came to know that, we know that every electrode having its own potential. If it is so, the next question is, if every electrode having its own potential, how to measure the potential? How come we know about the potential value of each and every electrode? That can be potential of each and every electrode can be measured by taking the help of standard hydrogen electrode. So as all of you know, with the help of the standard hydrogen electrode, we find out the potential of all the other electrodes. What we do generally is, we take a standard hydrogen electrode. A standard hydrogen electrode generally consists of a platinum electrode coated with platinum black. The electrode is dipped in a solution of 1 molar HCl solution, and pure hydrogen gas is bubbled through it at atmospheric pressure. This is how standard hydrogen electrode is constructed. This standard hydrogen electrode is used to measure the potential of all the electrodes, as all of us know. And this is the pictorial representation of the standard hydrogen electrode. It is just for your information. We don't discuss about this anyway. So we pass hydrogen gas, and we have taken 1 molar HCl solution. And this is how SHE is constructed. And with the help of this SHE, we measure the potential of any other electrode. And the SHE is represented by using the representation. Platinum is in contact with hydrogen gas. It is in turn in contact with the H plus ions of 1 molar concentration. And Conventionally, we have taken potential of standard hydrogen electrode at 298 Kelvin as 0. Conventionally, we have taken the potential of standard hydrogen electrode as 0. Therefore, whenever we try to find out the potential, when we want to find out the potential of any other electrode, what we do is we construct a galvanic cell by coupling standard hydrogen electrode with the other electrode. For example, let us say I want to find out the potential of zinc electrode. Then what I do, I take zinc electrode where zinc rod is dipped in zinc nitrate or zinc sulfate, and I connect that zinc electrode with standard hydrogen electrode externally through a circuit as well as internally through a salt bridge. Whenever I do so, in the external circuit, I also fix the voltmeter, a sensitive voltmeter. Whenever I do so, what happens is the deflection in the voltmeter will indicate that out of standard hydrogen electrode and the zinc electrode, out of these two, which is acting as the cathode, the deflection in the voltmeter will show us. Thereby, suppose I want to measure the potential of zinc electrode. What I do is I couple the zinc electrode with SHE. The moment I do so, with the help of the voltmeter in between, the voltmeter deflection clearly indicates out of zinc electrode and standard hydrogen electrode, it indicates that standard hydrogen electrode acting as cathode and zinc electrode acting as anode. And the voltmeter also shows how much of the potential is developed in the cell. The moment we come to know the potential, we know that the potential of any cell is given by the formula, that is potential of a cell is also called as EMF, that is electromotive force, and the electromotive force is given by the formula potential of the cathode minus potential of the anode, E cathode minus E anode. And in that case, potential of the cell, suppose in the case of zinc and SHE, potential of the cell is 0.76 volts, and potential of cathode is 0, SHE, and potential of zinc we have to find out. Therefore, if you apply this one, we come to know that the potential of zinc is going to be equal to minus 0.76 volts. In this way, by coupling any electrode with SHE, we can measure the potential of the given electrode by taking potential of SHE as 0. Potential of SHE as 0. In this way, potential of zinc electrode is measured as minus 0.76 volts. Potential of copper electrode is measured as 0.34 volts. Potential of iron electrode is measured as 0.41 volts. Potential of silver electrode is measured as 0.8 volts, and so on. In this way, for every electrode, we measure the potential by coupling that electrode with SHE. And the point is, the question may be arised, why the potential values of some electrodes are assigned with the negative sign, the potential values of some other electrodes are assigned with the positive sign. So the negative sign or the positive sign indicates that whether the given electrode is acting as anode with respect to SHE or acting as cathode with respect to SHE, it is indicated by negative sign or the positive sign. The negative sign indicates that the given electrode acting as anode with respect to SHE, and the positive sign indicates that the given electrode acting as cathode with respect to SHE. So for example, the potential of zinc is minus 0.76 volts. That means what? The zinc electrode is acting as anode with respect to SHE, or other way around, zinc undergoes oxidation upon coupling with SHE. Similarly, the potential value of copper is plus 0.34 volts. That means what? Copper electrode acts as cathode on coupling with SHE, or copper electrode undergo a reduction with respect to SHE upon coupling with SHE. In this way, dear students, by coupling with SHE, the moment we come across, I repeat once again, the moment we construct any new electrode or the moment we come across any new electrode, the first thing what we do is we couple that electrode with SHE at 298 Kelvin under standard conditions, and we measure the potential value of that particular electrode. And we assign that value and assign the value with either the positive sign or the negative sign to indicate whether the given electrode acts as anode or cathode with respect to SHE. In this way, we measure the potentials of all the existing electrodes. And therefore, what is this potential then? What is this electrode potential? Electrode potential of any given electrode is nothing but the measure of the tendency of that electrode to undergo reduction with respect to SHE. I repeat once again, The electrode potential of any given electrode is nothing but the measure of the tendency of that electrode to undergo reduction with respect to SHE. That is what is called as electrode potential. In this way, so that means what? Some electrode may undergo oxidation with respect to SHE, some may undergo reduction with respect to SHE, but conventionally, throughout the world, to have a uniform understanding, what we have done is we measure the reduction potential with respect to SHE. The ability of an electrode to undergo reduction with respect to SHE is what is called as electrode potential of the given electrode. In this way, dear students, what we do is whatever the electrodes we come across in research or in studies, for all the electrodes, we measure the electrode potential by coupling those electrodes with SHE. Once we do so, we arrange those electrodes, we arrange all the electrodes in the increasing order of their potentials. That is what we call as electrochemical series. We do, whatever the electrodes we come across, for all those electrodes, we measure the potential with respect to SHE, and we arrange all the electrodes in the increasing order of their potentials. That is what is called as electrochemical series. Once again, dear students, one second, I'll share the screen. ವಿನಯ್ ಶೇರ್ ಆಗ್ತಾ ಇಲ್ಲ, ಇದು ಪವರ್ ಪಾಯಿಂಟ್ ಓಪನ್ ಆಗ್ತಾ. ವಿನಯ್ ಆಗ್ತಿಲ್ಲ ಇದು. Okay, dear students, there is some problem in the network here with my computer probably. I'll continue this in the tomorrow's session, that is 2 o'clock session. Let me do one thing in tomorrow's session. Let me straight away take the questions from these 2 chapters, the important questions which can cover most of the important aspects of this chapter. There, I'll cover up both the theory part as well as the questions part. Sorry for the disturbance. There was some problem. I also could not correct it. Please excuse me. Okay. Tomorrow we will discuss the question and answers from both the chapters. We will cover up as much syllabus as possible with through questions and answers only. Thank you.